Class 9 Chemical Bonding. In our previous video, we learned about the valency or the combining capacity of the atoms of elements and ions. In this video, we shall learn how the atoms involve themselves in forming a molecule of a compound or an element. Atoms are the building blocks of all matter. But all atoms cannot exist single or individually under normal conditions. Only the noble gases, that is helium, neon, argon, krypton, xenon and radon, are able to exist independently. Other atoms group together as molecules by an attractive force between them called as bond. A chemical bond is defined as the force of attraction between the atoms that bind them together as a unit to form a molecule. Kossel and Louis approach to chemical bonding. Atoms of different elements combine in different ways to form different chemical compounds. In 1916, Kossel and Louis proposed a theory based on the noble gas electronic configuration to explain the chemical combination between atoms. It is known as electronic theory of valence or octet rule. Atoms of noble gases have little or no tendency to combine with each other or with other atoms of elements. This shows that they have a stable electronic configuration. Electronic configuration is the arrangement of electrons in the different orbits of an atom of an element. This arrangement varies for different elements. Let us see the electronic configuration of the noble gases. Helium, atomic number is 2 and the electron configuration is 2. That is, the orbit contains 2 electrons alone. Neon, atomic number is 10. Configuration is 2 and 8. That is, the outermost shell has 8 electrons. Argon, atomic number is 18. Electronic configuration is 2, 8, 8. So we see that the number of shell is increasing, but the outermost shell has 8 electrons. Krypton 36, 2, 8, 18, 8. Xenon, atomic number 54. Electronic configuration 2, 8, 18, 18, 8. Radon, atomic number 86. Electronic configuration 2, 8, 18, 32, 18, 8. Except helium, all other noble gases have 8 electrons in valence shell. Helium also has its valence shell filled completely but with 2 electrons. Thus, by having stable valence shell or completely filled valence shell, the noble gas atoms do not tend to gain or lose electrons, so their valency is 0. The atoms of noble gases exist as monoatomic gaseous atoms. Considering this nature of the stable valence shell electronic configuration of inert gases, Kossel and Louis proposed that atoms of all other elements combine to form molecules because they have incomplete valence shell. And so they try to attain stable electronic configuration by either transferring or sharing the valence electrons in the outermost orbit. The tendency of atoms to have 8 electrons in the valence shell to achieve stable electronic configuration is known as octet rule or rule of 8. Atoms with electrons less than 4 electrons in the outer shell tend to lose their electrons and form positive ion. Atoms with electrons more than 4 in the outer shell tend to gain electron and become negative ion. Atomic number of sodium is 11. Its electronic configuration is 281. That is valence electron less than 4. So it loses its one electron in the valence shell and becomes a positive ion to attain octet configuration. Atomic number of chlorine is 17. Its electronic configuration is 287. That is, its valence electron is greater than 4. So it gains electrons and attains octet configuration and becomes chlorine negative ion. Louis proposed a symbol to denote the valence electrons of atoms, and it is called as Louis dot structure. Louis dot structure. The valence electrons of atoms are involved in bonding of atoms to form a compound. So Louis proposed the Louis dot structure or electron dot symbol to depict the valence electron in the atoms. In Louis structure, the symbol of the element is surrounded by dots representing the valence electrons. The unpaired valence electron is represented by a single dot, example hydrogen, and the paired ones by double dots, example helium. Dots are placed on each side of the letter until all four sides are occupied. Example carbon. Then dots are written two to a side until all valence electrons are accounted. Example nitrogen, oxygen. Symbols other than dots like crosses or circles may be used to represent electrons of different atoms of a molecule. Types of chemical bond. Different types of chemical bonds are formed since the elements have different valence shell configuration. These bonds are classified into two main types, namely the strong bonds and the weak bonds. Strong chemical bonds are ionic bond, covalent bond, coordinate bond, and metallic bond. Weak chemical bonds are hydrogen bond and van der Waals interaction. Depending on the type of bond, the properties of the molecules vary. In this video, we shall see about strong chemical bonds and their characteristics. The ionic bond, ionic or electrovalent or electrostatic bond. This type of bond is formed between two atoms when one or more electrons are transferred from the valence shell of an atom to the valence shell of another atom. When an atom loses its valence electron, it becomes a cation or the positive charge, and the atom that gains the electron becomes an anion, that is negative charge. These oppositely charged electrons come closer to each other due to electrostatic force of attraction, and the ionic bond is formed. Example, the bond between sodium ion and chlorine ion in sodium chloride, potassium ion and iodine ion in potassium iodide, calcium ion and chlorine ion in calcium chloride. Ionic bond is a chemical bond formed by the electrostatic attraction between positive and negative ions. Since the bond occurs between ions, it is called as ionic bond. As it is the electrostatic force that bonds the atoms, it is called electrostatic bond. Since valence electron concept plays a part in the bond formation, it is also called as electrovalent bond. Ionic bond is formed between metals and nonmetals. Alkali and alkaline earth metals form ionic compounds with nonmetals. Let us see the formation of ionic bonding in sodium chloride. Formation of ionic bonding in sodium chloride. Atomic number of sodium is 11. Electronic configuration of sodium is 2, 8, 1. Atomic number of chlorine is 17. Electronic configuration is 2, 8, 7. We see that sodium attains stable octet configuration by losing its one valence electron and becomes sodium positive ion or sodium cation. Chlorine attains stable octet configuration by gaining one electron in its outermost shell 288 and becomes Cl minus ion or chlorine anion. Due to the electrostatic attraction between the sodium positive ion and chlorine negative ion, an ionic bond is formed between them and the compound sodium chloride is formed. Similarly, the formation of the ionic compound magnesium chloride can also be explained. Magnesium atomic number 12, electronic configuration 282. Stable configuration or octet configuration is 28. The ion formed is magnesium 2+. Chlorine atomic number 17, electronic configuration 287. Stable octet configuration is 288. So the ion formed is Cl minus. Two chlorine atoms will gain the 2 electrons lost by the magnesium atom, forming 2 Cl minus ions. The force of attraction between one magnesium ion Mg2 plus and 2 chlorine ions 2 Cl minus leads to the formation of ionic bond between them to form magnesium chloride. Characteristics of ionic compounds. Let us now see the properties of the compounds formed by ionic bonding. Physical properties. Since these compounds are formed by strong electrostatic force, the cations and anions are arranged in definite geometric shape. So, ionic compounds are crystalline at room temperature. Number 2, melting point. The electrostatic force of attraction between the cations and anions is very high. So, very high energy is required to break the bonds. So, ionic compounds have high melting and boiling points. Solubility. Ionic compounds are soluble in polar solvents like water and insoluble in non-polar solvents like benzene, C6H6 and carbon tetrachloride CCl4. Number 4, density, hardness and brittleness. Due to the strong bonding because of the electrostatic force, ionic compounds have high density and hardness, but they are highly brittle. That is, they can be broken easily. Number 5, reactions. Ionic compounds undergo ionic reactions which are rapid and instantaneous. That is, quick and immediate. These are the important properties of ionic compounds. Let us learn about the covalent bond and the other strong bonds in our next video, Chemical Bonding Part 2. Hope you are clear about the formation of ionic compounds. Thank you for watching. Please like, share, subscribe and click the bell icon.